Okay, so this is a little bit of practice on collinear and coplanar points. First of all, remember collinear means points that lie on the same line. Coplanar means points that lie on the same plane. So a couple of notes to remember before we look at this next diagram is collinear points on the same line. Remember, 2 points are always collinear. It doesn't matter where they are, whether the diagram draws a line between them or not. 2 points are always collinear. Also, please remember that 3, well, let me erase a little bit. 3, got to be careful, non-collinear points. So 3 points that aren't on the same line are always coplanar. So if you have 3 points that are not all sitting on the same line, you have to be able to make a plane that connects all of them. Another thing to remember is 4, and we'll put 4 plus. So 4 and up points can be coplanar, but don't have to be. So 3 non-collinear points don't have a choice. 3 non-collinear points have to create the same plane, no matter what. Now, 4 points can all lie on the same plane, but they do not necessarily have to. As we discussed before in class, that's why a 4-legged chair sometimes wobbles, but not always. But a 3-legged tripod or a 3-legged stool never, ever wobbles. It does not have a choice. So if we take a look here at an example, what are some things that I could ask you? Well, let's name some collinear points. Well, so collinear points, we're looking for points that lie on the same line. We know that A, B, and E, those would be 3 collinear points. B, C, those are collinear points, but then it gets tricky. What if I asked you, are C and D collinear? The answer is yes, everybody. C and D are 2 points. 2 points, no matter what, are always collinear. B and D, same thing. A and D, E and D. Those are collinear points because they are 2 points out in space. They must be collinear. Well, let's talk coplanar. Coplanar points are points that lie on the same plane. B, C, and D are all points that lie in the same plane. They're all in this gray plane right here. So B, C, and D are 3 non-collinear points, so therefore they have to be coplanar. What if I asked you, how about D, B, and E? Yes, they're coplanar. They're 3 non-collinear points. They must create a plane. B, D, and E are all coplanar. A, B, and D are coplanar. A, C, and D are coplanar. A, C, and B are coplanar. Now, what if I asked you, are B, C, D, and E coplanar? That one's no, because E is below the gray plane while B, C, and D are sitting inside of it. If you pick any of those 3, the answer is yes. But since I threw in that 4th one, the 4th one can be, but doesn't have to be. And in this case, B, C, D, and E are not coplanar, just like B, C, D, and A are not coplanar either.